Thanks, Foster. And we have a couple more special presentations. One is being brought down. Everybody's from Vermont, is that right? Vermont and New Hampshire. Didi Pershouse is a friend of ours from Thetford, Vermont, and she's visiting, and I'm going to let her introduce the students that she brought with her that she's been working with. And Didi is connected with the Soil Carbon Coalition, which founded by Peter Donovan, who was mentioned earlier today. And they're all about measurements of soil carbon and promoting a healthy interest and almost competition in seeing how people on various places on Earth can increase the soil carbon in their soil. So Didi, come on up and you can introduce everybody.
Okay, so we need to go up to the first slide there. There we go. The Soil Carbon Coalition is the only organization doing long-term monitoring of soil carbon and water infiltration and plant cover and diversity on multiple projects in the United States, Canada, and Mexico. We have over 300 plots now, and we're growing every month. About a year ago, I realized that at conferences like this, including last year's, that there's this cutting-edge science going on, and that it's really, for the most part, other than a few pockets like Jim and Jane's work, it's not being taught in schools. So I set a goal to develop curriculum, and I'm a cross-pollinator, so we'll be doing that thing that you just did on stage here, probably next week. Collecting resources. I spent the last year meeting with scientists, farmers, ranchers, teachers, students, and soil health experts all over the United States and Canada to try to think about how do we put together curriculum and learning resources for students and also for community leaders so that we can really develop new leadership that understands how to collaborate with biological work to get things done. And I'm really pleased to have two students. I just started piloting the curriculum in schools in New Hampshire and Vermont in the last few weeks, and already leadership is emerging. I have Emaline Conkey from Mascoma Valley Regional High School in New Hampshire, and Brianna Klauer from Hartford High School in Vermont. And I'm going to let them take it away because after 10 days of class, they already know enough to really dig in deep to everything they've been hearing here already and to present themselves at an international conference. And I think that's pretty darn cool.
Hi, so I'm going to talk about what we've been doing in class. And we've been doing a lot of things outside because we've had a lot of good weather. And this is the water infiltration test that we're doing. And we're doing it in 4 different places on our property at school. We're doing it in the garden, over near the football field, the woods, and the front of the school. And when we did this, we had 3 tests in each area, and we averaged the times out. And I'm not sure what the times were for the other groups, but and I led a group, and it worked out pretty well. And we did some other things. We did some bulk density, and we did that in the 4 locations. And we were working on finding all of that, and we're going to send them off to UVM, and we're going to have it tested. And for soil carbon, and we've been learning a lot more in class, and I've been the one that's the most interested in it, I think. So, and I am showing the most interest, so I'm like, everybody wants me in a group, basically. So, because they don't understand it, but, and we've been this is in class when we've been learning about the importance of the soil carbon and how we can get it into, and how we can like get the soil aggregated and all of that, and what matters along with it, all of it. And nobody really knew about this until we started to bring it up, and then everybody put it all together and realized that it's a really big deal, and it's good, it matters, and we're like, I don't know, what else are we saying? But yeah, and and we've been doing probe testing, and we've been doing those in all of the locations too, and the soil is really compact around here, and we've only been getting like 25 to 30 centimeters into the ground, and I believe we're supposed to be getting around 45, but it's not working for us, so we've been just doing around 30 and then using the 10 centimeters for the A, B, and C, and we've been testing them this past week for nitrate, phosphorus, and ammonium. And we were finishing that yesterday, but I left for here, so I'm not sure what the results were. And we looked over this in class, and she showed us this when she first started to come and teach. And we've been putting them all together and finding out which ones are like the biggest ones and what the soil carbon like is around, and how they're all pieced together and they're not separate, and how it all ties in together. And we've been working on a lot of other things too, like we've been watching a bunch of videos on it too, and we've read some stuff on it, and we've been trying to go outside mostly to get samples, and it's working out pretty well. And we've only been doing it for like 2.5, 3 weeks, and we've been well into it, and we've done more than her school because they haven't had really good weather at theirs. But and I think that's really what we're doing at school. And then you want to
Do
keep
we
going?
want to do the other one first, and then we'll go back into that one?
Where is it?
So it should be on the main page, so if you just go and zoom out of that, and then right there. Okay, so I'm gonna have you pause it so I can explain stuff.
Okay.
Okay. Yeah, just pause it there. So this is only a partial clip of a full movie that I made for the Breakthrough Challenge through Khan Academy. And the main goal was to pick a topic in either mathematics, physical science, or life science. And because I'd been introduced to this topic through Mrs. Pershouse, I decided, hey, I'm learning more about this. Why not, as I learn this, putting it into something so I could submit it. So most of you know that soils are kind of the building block of our plant's sustainability. And without them, we don't really have anything to base any of our agriculture off of, our infrastructure. We're solely dependent on our soils. So we can go to the next one. So in addition to allowing us to have strong agricultural system of soils, also they prevent flooding, runoff, drought, allow us to build a stable infrastructure, and they filter our water. So when soil isn't healthy and it's not filtrating through our soils and going through all the pores and going through the water cycle and helping just clean everything out, all that runoff is taking all of those particles and fertilizers and pesticides that aren't so good for us into our water. And if that gets down into the water table or into our lakes and our streams, that's never healthy for us or the fish species and all the other microbial life that we depend on. So, and they do this through photosynthesis, where the plants take the CO2 in through their leaves, and with the sunlight and water convert it into carbohydrates in the forms of like glucose, and that helps with the plant structure grow, root structure, and the extra carbohydrates are returned to the soil, where the microbial life takes in that carbon and then develops that into make pore spaces and the biological glues that hold our aggregate structures together. Yep. And that's just diagram. Let that play through. Okay. And this is just a basic diagram of aggregate structure. And again, those snot slimes and glues that those microbial life forms make and hold the soils together, create those pores, so we have good infiltration through our soil so it can sustain the plants that are feeding them in the long run. Okay. Yeah. And so, yeah. So wonderful bacteria and the fungi also extend the root structures. And again, snot slimes and glues stick stuff together. And if the ground isn't covered and the ground heats up, then it's killing off all those microbial life forms. And if there's no microbial life forms, then there's no carbon being reproduced, no pore spaces, and those pore spaces collapse, there's no aggregate structure, and there's no plant life. And it's just a constant downfall from there. The ground just deteriorates and gets eroded away. Yep. So yeah, and the size and number of the pore spaces in an aggregate define how well water and air can move through the soil. So if there are no pore spaces, obviously it's not going to be doing much for us, and it's not going to produce the things that we need to survive so we can help give back to it. And if it's not giving back to us, then there's nothing we can do other than to start the holistic management and stuff like that and try to get it back to the natural running order that it needs to be sustainable for us. Yep. And yep. I'm sure most of you have probably seen this picture before. This is from South Africa, taken by the Savory Institute. This side was reformed by holistic management with sheep to mimic herds, like natural grazing herds. And so when soil is healthy, full of life, and well aggregated, there's lots of room for water. So good pore spaces, the water's infiltrating, feeding all that microbial life and doing all the good stuff, and then we get these nice strong grasses that are holding our soil together. And on the other side, if you want to play that. Okay, so I'll pause it real quick. Okay, so when the soil is unhealthy and compacted and desertified, it lacks these pore spaces, so all the pore spaces have collapsed. There's no infiltration. The water's just sitting there and getting evaporated, going back up into the atmosphere and not doing anything, and it's not getting filtered through. It's not reaching the water table or our lakes and streams, and if it's running off instead of evaporating, it's taking all the gross stuff with it. Okay, so without aggregates, soil easily erodes and is washable in a way. So as you can see, over time, there's nothing been holding those banks together, and between wind and water, it's all just getting washed away, and it's ending up not serving its purpose, which is to be sustainable and produce things that are going to give back to the planet as a whole. So if you want, you can go back to the other slide. The next thing we're going to show you is, yep, just that's it for that. Okay, the next thing we're going to show you is it's an analytical demonstration. It's an analogy of using flour and bread to compare like collapsed soil structures with no pore spaces. And the bread will represent healthy soil that has lots of pore spaces and is well aggregated. So, this is a quick little demonstration just to compare aggregated soil versus unaggregated soil. So our flour here represents our poorly aggregated soil, doesn't have a lot of pore spaces, and our bread has all these nice little pore spaces in it, so our water infiltrates really, really well. So, this styrofoam cup, poked a few holes in it to simulate rain. First thing I'm going to do over the flour, just so you can see, just kind of runs right off, doesn't really go through, runs off, carries all these particles with it, like poorly aggregated soil would do, if it were to rain naturally. And all this stuff would end up in our streams and our lakes, and that's not healthy. But over our bread, you can see that most of it is absorbed almost instantly all the way through. Wow. See, even if it were to rain really heavily or if there were to be a flood, it still enters relatively well versus, well, come back over here to the flour, it's just running off. Pore spaces, again.
Which soil would you rather have?
Definitely the bread. That is my class. We have a 55-minute period every single day, and Mrs. Pershouse came in at least 3 times a week for a period of about 2.5 weeks. And we didn't have the greatest weather, so we didn't get to go outside every day. Like the first day she came to our school, it was pouring, and we all either had to go get rain jackets or go find a contractor bag and go outside. So that was the first day. We looked at how the water was running off on our campus, and actually half of our campus is actually under renovation right now. So we actually ended up going down onto our football field, which every time we get heavy rain, like half the football field floods. So that can tell you how good our soil is. So it just like puddles in the same spot every time, and there's just all this silt that runs off and kind of destroys the field. Yeah.
And at our school, we have 75-minute blocks, and she comes in, she came in for 2 weeks straight for the 5 days. And we went outside for the majority, and it was pretty interesting. Everybody had fun, I think, going outside. Just the majority sitting inside wasn't very interesting, everybody thought so. And I think that's really it. And then we just wanted to thank her and my teacher, who's not here, and a few sponsors. Which do you want to say?
So thank you to the Vermont Community Foundation for the seed grants, New Hampshire Entrepreneurs Foundation, and Wellborn Ecology Fund. And we are looking to raise $100,000 to bring this work to schools across the country. It's not included in almost every curriculum across the United States. And I think it's really important that kids start learning more about this, because if they're not hearing it in school, where else are they going to hear it? And how are we supposed to help our planet if we're not teaching our kids what's wrong with it and what we're doing?